The year is 2126, and you're watching the Earth rise on a new day from the comfort of your home on the moon. NASA just wrapped phase 1 of building the first city on the moon, and while everyone talks expansion and new architecture, it's still the most lethal environment humans have ever faced. You thought Antarctica was tough. Well, at least it had oxygen. Today, you're going to deep dive into our potential future and experience the reality of living on the moon. And spoiler alert, it's treacherous. This morning, you're taking the monorail out to your dig at the solar farms. Yeah, on the moon, everything has to have power, and solar panels are big, flat things that pack up and ship nicely. This is your first real outside gig, rewiring solar panels powering Luna Prime and inspecting the ancient radioactive heater units. And you're stoked. This is an exciting time to be a loony. But that title isn't unearned. You've got to be a little crazy to live here. It's extra deadly without any shelter overhead. Micrometeorites fly faster than sniper bullets, and a single tiny asteroid going 50 miles a second can puncture your oxygen tank, crack your helmet open, or put a hole right through the middle of your skull. Every job up here is dangerous work, and humanity's needed to overcome a staggering number of threats just to stay alive. To start, at the moon's equator, there are 14 days of darkness a month. Ugh, scary. And cold. Yeah, let me tell you about the temperature differences. It can reach 127 degrees Celsius in the sunshine, but in the shadows, it plunges to minus 173 degrees Celsius. You ever try starting a car at minus 30? Yeah, this is way, way worse. Plus, there's barely any atmosphere or magnetosphere, which means no protection from the sun's radiation. An abrupt solar flare can shred your DNA to ribbons. There's no air, nothing to eat, and few resupplies. But it's 2126, and humanity's figured out technical answers to most of these problems. But why? Why would anyone go through hell to build a city on the moon? Because everyone who lives up here, you included, is crazy enough to see this moon base for what it really is. A gateway to the universe. Every day feels like history, staging a flight to Mars, the belt, or beyond, or inward. Literally, everywhere in the solar system is hundreds of times easier if we start the journey with a full tank from the moon. And why is that the case? Well, those small steps of Neil Armstrong and Buzz Aldrin are the answer. Low gravity. To launch a rocket from Earth today, you need to achieve 35,000 kilometers per hour, 22,000 miles per hour, and that's just to get into low Earth orbit. To achieve that speed, 90% of the rocket's weight is fuel. Imagine if you had to fill 9 extra cars worth of fuel for your car just to leave your driveway. But on the moon, you're walking around in 16% Earth's gravity. Any launches you make from the moon are therefore 84% easier. And not only that, but with no atmosphere, new launch technologies can be feasible options. Like a railgun that uses electromagnets to accelerate your payload into orbit. It's been an astonishing feat of engineering just to get to this stage. To survive, the city needs constant power, oxygen, and water. Plus comms and server barns, all encased in buildings that can survive extreme environments and store energy. Luna is not just a city, it's a life support system. And every day, there's always the possibility that the pulse of the city could flatline because one computer glitch sends all the oxygen out the back door. Terrifying. And what about gravity? Well, doesn't living in low gravity hurt the human body over long periods of time? Well, stick around till the end of the video to see the details of how you solve that. So, how does this city actually survive up here? Well, it comes down to one thing: materials, resources. And there's one in particular doing a lot of heavy lifting: graphite. Graphite would be at the heart of this entire system. As the largest mineral component in lithium-ion batteries by weight, graphite plays a critical role in the massive battery systems that store and deliver energy across the city, turning energy into stored life and helping keep the city alive through the 14 straight days of lunar darkness. It helps stabilize power so that nothing suddenly shuts down. But it doesn't stop there. What makes graphite so useful is how it behaves at a fundamental level. More than a mineral, it's a technological enabler, highly conductive, incredibly stable at extreme temperatures, and chemically resilient, which means it can move energy efficiently, manage heat, and keep systems running even in harsh environments. That's why it would show up everywhere. In computing systems and data centers, AI is constantly managing oxygen, heat, and energy use. In modern communication systems, keeping a stable link to Earth, even in complex electromagnetic environments. Even in advanced materials, lightweight, heat-resistant composites designed to survive extreme conditions. Now, it might sound crazy that this one mineral could be the key to so many critical systems, but this is already happening on Earth. So, all NASA's had to figure out in the last century is how to safely duplicate what we have on Earth: air, water, food, heat, shelter, and not going crazy. Going crazy might not seem like a huge risk. You're out here for an adventure after all, but cabin fever is real. In 2011, the Mars 500 project simulated what it would be like for a year-long voyage to the Red Planet, with crew members undergoing realistic conditions. No real-time communication with family, limited entertainment options, and limited living quarters. At first, the trip was pleasant, with participants all enjoying each other's company. The return trip, however, basically had all participants keeping to themselves. A social ghost ship, and that was only after 1 year of a 500-day planned mission. You're up here on the moon permanently. Now, as you wander from solar panels to the original heater units, which are 95 years old at this point, you wonder, how the heck did they go from a crater to a self-sustaining city? Well, it all started back in the 30s, the 2030s, when NASA built its first habitats on the moon, if you could call them that. Now, you've lived in Luna Prime for 10 years now, so you've done all the touristy stuff, including the historical tour. The first living quarters looked like 4 thermoses welded together with bottle caps. Now, of course, the idea of living on the moon started way before that. People have been spinning stories about it since we were munching mammoths around the campfire. Those sci-fi tales from H.G. Wells to Heinlein became reality when Armstrong and Aldrin touched down in 1969. Yeah, they famously walked on the moon, but they also lived on the moon for 21 hours. Sure, it was in a lander with about 8 feet of living space, but the 2 astronauts did report eating and attempting a brief nap. In 1972, after Apollo 17, humans stopped going to the moon for a little while. But in the 2000s and 2010s, a discovery was made that completely switched the narrative: water. It was discovered in the lunar soil. This made establishing a permanent base a lot more feasible, because we humans need that water. Plans were drawn up to return to the moon and establish habitats. In 2026, the now legendary Artemis II mission became the first crewed flight around the moon in 50 years, firing up humanity's imagination for a moon landing in 2028. And by the early 2030s, NASA had people living on the moon, at least part-time. To start, they lived like Buzz and Neil, sleeping in their human landing systems, which don't sound like a nice place to attempt a nap. But eventually, those blow-up thermos-style habitats became reality, creating a semi-permanent crew presence. The habitats were good at deflecting solar radiation, but the process of getting in and out of them is laborious. Suiting up and leaving the habitat takes hours because lunar regolith gets everywhere, in every gasket, every hinge, on every surface, and eventually an air leak leads to decompression. Not good. So maintenance is an essential part of moon life, unless you want to be the first grave on the moon. Within a couple of decades, once the 3D printers and water mining got going, humanity started building more permanent structures right out of the lunar regolith. Domes, all the domes. Technology already on Earth today allows lasers to weld the lunar regolith together to create a form of moon concrete. It uses a process similar to powder bed fusion, where it melts the regolith powder into a molten state, which then recrystallizes into structural ceramic. Moon laser habitats, yeah! By the time you arrived, Luna Prime was housing over 1 million people, with better transit than most Earth cities. Now, if you're wondering, how did they do it all at scale? How did they secure air, water, food, heat, and shelter for 1 million plus people and not get everyone killed? Well, it's a great question, and the only good answer is science. Well, technology and human ingenuity in the face of overwhelming odds. And science. It was fitting that NASA chose to build Luna Prime on the Shackleton de Gerlache Ridge near Shackleton Crater, named after the intrepid explorer. The ridge is located by the moon's south pole. By wisely choosing to build there, they subverted at least 3 of the most challenging problems the moon presents. First, they avoided the lethal 14-day nights that plague the moon's equator. So new loonies didn't have to spend half their lives in deadly cold darkness. At the South Pole, there's always some sunlight available. It's eerie. The sun hangs low in the horizon all the time, casting long shadows everywhere. But it's a worthwhile trade-off. To keep gear warm in those shadows, NASA brought the radioactive heater units you're checking today. Basically, pellets of plutonium in a protective container that kept machines from freezing solid. They're safe-ish, but a breached unit could give you radiation poisoning. It's still freaking plutonium. If you got sick on the moon, well, there's just the triage center back at the base, but they're not equipped for anything and everything like on Earth. No, up here, you break an arm or get radiation poisoning, you get the same treatment. Rest and hope for the best. Maybe a little Tylenol. Second, sunlight equals power. Solar power. Not only did NASA's nascent city avoid freezing blackouts, its solar farms, like the ones you work on, had access to solar energy 24/7, feeding into massive battery banks, which, as an aside, are basically a third graphite. Nuclear reactors provided constant backup. Third, there are sites of permanent darkness near the poles that never see the light of the sun deep in all those craters. Shackleton Crater is twice the depth of the Grand Canyon. I know what you're thinking. Darkness? Great. But billions of years of permanent darkness created a unique environment that preserved volatiles. That is, ice, which equals water. Delicious, icy water. As an added bonus, there are spots on the South Pole where direct, constant communication with Earth is possible. No interruptions. By just choosing the right location, NASA gave Luna Prime a way better chance of success than perhaps anything else that it did. Soon, NASA started running regularly crewed missions to establish a semi-permanent base. They focused on getting gear to the moon's surface with their crews or through commercial lunar payload services. Basically, space couriers, which delivered rovers and moonfall drones. They also had to deliver basically every meal for every crew member, and they needed to do it for a long time. If you want to grow food on the moon, you need a lot of space, water, technology, and time. On Earth, you typically want somewhere in the range of 1/2 to 1 acre per person for a fully sustainable life. But that much land just isn't feasible to take care of on the moon. Walking around on the surface is cumbersome, and any trip or scratch of your suit is lights out. Hydroponics are one solution for growing food on the moon, vertically. In a temperature-controlled building with artificial light, low-gravity compatible plants can be grown. So, what crops could even grow in low gravity? Well, leafy greens, peas, and vegetables have all been grown in various experiments back in the days of the International Space Station. And back in 2022, Chinese researchers aboard the Tiangong space station grew rice grains for their complete life cycles, from seed to grain and all the way back to seed again. That's an important step because getting anything, even seeds, to the moon is extremely costly. In 2026, Astrobotic quoted $1.2 million per kilogram to get something to the moon. And you don't want to be shipping carrot seeds for the next 20 years. If you can propagate and replant your harvest, well, now you're in business. Moon business. After a few decades of living in thermoses and with enough tools to start building, your grandparents really tackled mass shelter. And that's where all those domes built from moon dirt, regolith, came from. Lunar regolith is a pain. Sharp, sticks to everything, but it's a surprisingly useful building block full of oxygen, silicon, iron, and aluminum. That provides glass and metal for the domes. Why is it always domes on the moon? Well, on the moon, everything needs to be pressurized, and domes are the most stable architecture for pressurized environments. So, humans started making bricks and 3D printing domes out of regolith concrete, mined iron, aluminum, and silicon. Habitats were heavily shielded to protect loonies from micrometeorites and the deadly irradiating solar wind. After a few more decades, humanity had domes, plus oxygen, power, food, and once mining operations in the craters took off, water. So, with all that widely available, NASA started bringing people up to live on a more permanent basis. Lunar space elevators made getting people back and forth more feasible. Some people rotated through a year at a time, but some stayed. Eventually, the habitat became a village, then a town, and then a city. And to be clear, it wasn't the only one. Down the road, China built its own city on the Sverdrup-Henson crater. India and Russia also built nearby. The Artemis project involved the Canadian, Japanese, and European space agencies from the early days, so Luna Prime always had a significant international presence. Fortunately, the moon, like Antarctica and the International Space Station before it, is generally cooperative. Mostly by necessity. Everybody knows they're in a precarious situation together. Plus, real armed combat is phenomenally deadly in pressurized habitats. If there was ever an incident or a shootout, well, let's just say the general rule is guns in space equal habitat decompression, oxygen tank explosions, fires, and everybody dies. And As the population of scientists and techs grew, well, they soon started to need other specialists, doctors, nurses, teachers. Yeah, that's right, kids started appearing, as they do when people congregate. In your day, it's no big deal when kids are born on the moon, but that said, humans didn't evolve to live in low gravity, so health problems are abundant. The only solution is to add gravity back. Luna Prime has exercise gyms in spinning centrifuge-like habitats that simulate Earth's gravity. Residences are similarly built to keep people from suffering the worst effects of low G. The diameter needed to sustain comfortable living conditions in Earth-like gravity isn't even that large. According to a NASA study completed in 2015, only about 1.5 kilometers spinning at 1 revolution per minute. Any smaller than that, and your head experiences significantly less gravity than your feet do, so bending over and turning around become nauseating experiences. Though with enough spin-up time, people could survive in habitats that are as small as 50 meters, spinning at 6 revolutions per minute. You don't, but it is theoretically possible. Living in tight, regulated quarters with the potential for death on the other side of every wall isn't for everyone. But you love it. You used to be terrified of the micrometeorites that you can see have hit the lunar surface, but you've never actually seen one. It feels like a distant fear now, though it's not really something that'll happen to you. And you love being on the surface of the moon. It's like being a couple hours drive outside the city and looking up at the crystal clear night sky. It's just you and the stars, looking up into the totality of the universe. Because the moon has no atmosphere, night and day have no difference when you look up in the sky. It's always black, always starry, and since the moon is tidally locked with Earth, you always get to see your homeworld whenever you want. Just look up. As you check the old heaters and scuffle over the footsteps of those techs and astronauts who established Luna Prime, well, you can't help but appreciate their work. And imagine what it was like way back in 2026, after Artemis II. The world is at a tipping point, finally planning to go back to the moon for the first time in 50 years. Within a decade, NASA and its fellow space agencies would build a base on the moon that would signal the potential exploration of the solar system, of the universe, to the whole of planet Earth. You imagine what it would be like to look up at the night sky for the first time in the mid-2030s and see another world with the lights on. Sure, there are times you miss Earth and wish you could just order a burger and go outside, but it's worth it to be part of the grand human exploration of the galaxy. You also wonder how long it'll take before humans colonize Mars and the rest of the solar system, then onto the rest of the galaxy, and finally become a Type 3 civilization. But that's a story for another What If.